Good morning. Good morning, and thank you for inviting me here. I want to start with the slides, make sure everybody understands the terminology. I know this is a conference that's all into A/B testing. Here's a typical A/B test. You got people, and I'll use the term that are slightly more academic, the control and the treatment, an A/B equivalent. You instrument users' interaction, and the point is to instrument as much as you can, get a lot of data about what's happening. We instrument both the client and the server side, so we know percentiles of time spent in the server and cache hits and a lot of things like that. And then you do the analysis at the end. So mechanism is very, very simple. An A/B is the simplest control experiments you can run. You can think of ABN, which is a univariate experiment. You run A, B, C, D, E. We tend to like those. We encourage people on our teams to try to do more variants because, as you'll see, a lot of the results are surprising. There's also a whole area called MVT, multivariate or multivariable testing. We don't use these enough, and you can see in the papers, we think in the online world, you're better off launching experiments more quickly and then run them orthogonally rather than try to design for an MVT. You must run statistical tests. I think everybody here knows it. But the key point that a lot of people don't get is, what are we really doing here? We are proving causality. Right? The scientific method allows us to say that if we run these things concurrently, then with high probability, the treatment caused the metrics to change. And this is the heart of why we run controlled experiments. So I looked at the statistics that Pep shared. He sent this to us in advance. So 83% of the people that responded to the survey, which actually may be biased towards people that do run experiments, said they ran less than 30 experiments. Just to give you an idea of our scale, I'll talk about it more, we ship about 30 experiments every day. So large scale, and this is the graph of the actual experiment treatments that we've run. There's a couple of things. One is, it takes time to scale an org. Most of these by far are, this graph specifically is a Bing graph. So a lot of the beginning growth is a lot about culture. It's a lot about the ability to build a system, the platform that allows people to run experiments at scale. And there is a massive shift that happens when you're able to go from running user in a single experiment to running multiple experiments on the same user. Okay, and so people before talked about some allocation of users. We actually don't have this problem. Users are going to be in multiple concurrent experiments. So we typically finish about 300 treatments per week. As I said, mostly on Bing, but we're now starting to expand. We run on MSN, on Office, OneNote, Xbox. Now Xbox games, including Halo, has been running some experiments. Cortana, Skype Exchange, OneDrive. And by the numbers, I mean real experiments. I don't mean running an MVT that's got 30 by 10 by 10. We normally expose variants to about 100,000 to millions of users, sometimes tens of millions of users, especially when something is not trustworthy. I'll talk a lot about that, but when we have something that looks suspicious, we will pump up the power a lot. All users are in experiments, basically. We keep a global holdout to see that the experimentation system itself is not causing problems, but other than that, everybody's in experiments. In fact, users are in multiple experiments. Average user comes to Bing is about 15 experiments, concurrent. That means you're falling into one of 30 billion variants. Okay, there's no Bing anymore. It's a complicated system. It takes a whole new meaning to the word debugging. And then you can see from the graph that we did have an exponential growth. And so right now, we're at the point where the system is no longer a limit. Right? The limit is people's ability to code up ideas and come up with them and write them up. And you can see in the green, that's the mobile graph. It's starting to ramp up as Microsoft changes a lot of its focus to cloud, mobile, things like that. So I want to start with two valuable experiments. It's actually interesting to think about the definition of valuable. What is a valuable experiment? And here's my definition. It's the absolute value of the delta between your expected outcome and the actual outcome. What do I mean by that? If you thought something was going to work and you ran an experiment and all it did was confirm that you had a great idea, you haven't learned much. Your intuition is good, your idea is reasonable, the experiment just confirmed something. Where do you really get the value? If you thought it was going to win, You are sure this is a great idea, and it loses. Then it's valuable because there's learning in there. And we joke that as soon as groups start to run experiments and they were previously shipping things that they always thought was good, it becomes a very humbling experience. Our job is to tell them that their next baby is really ugly. Right? Everybody hatches these ideas, everybody has these babies that they love, and a lot of the times we tell them that their babies are really ugly. And then the other area where you win a lot, if you thought, this is a meh idea, why don't we do it in the background, let somebody do it in their spare time, and it became a breakthrough. That is extremely, highly valuable, and I have a few examples of that in this paper if you want to look at. I'll share one of them with you here. So I'll give you two examples. They ran at Microsoft Bing, each had millions of users. I'll talk about the OEC, the overall evaluation criteria, and this is how you decide if A is better than B or B is better than A or flat. And then, as usual, you can see if A wins or it's flat or if B wins. So here's a good example. That's, in advance, I'll tell you that it was very valuable. Okay, so the question was, should Bing add site links to ads? Okay, so here you can see on the left is a normal ad, and on the right, the fourth line has site links. Okay, and what do we care about for this experiment? Revenue. Revenue, by the way, is typically a reasonable metric to evaluate. Not always time because you have to look at long term, but for this experiment, we'll look at immediate revenue. But there is a problem with this experiment that I want to emphasize. Sort of a rule of thumb. If you give an element on the page more pixels, it will generally win on click-throughs. Okay, so if all I said was which is going to win A or B, B should win. Because I gave it another line. So in an experiment that we really care about doing correctly, we can't just say B. We have to limit B to the same vertical pixels on average. That makes the experiment a lot more challenging. So if you think about it, the pro of adding these lines is the ads are richer, they give users more information. The con is that I'm now constraining you to display either 4 ads of type A or 3 ads of type B. Okay, so the system, the optimization system at the end says, this query, I'm not going to display any ads. This query, I'm going to display one that's, got 4 lines. Or I could display, so 3 out of 4, I could display B. And in the version A, I could display more. So very, very hard problem now to say which is going to work, A or B. Okay, so let's just see if you guys how you guys think about it. Raise your left hand if you think A wins. Raise your right hand if you think B wins. And don't raise your hand if you think they're doing about the same, flat. Let's see what the audience thinks. Okay, a lot of people think it's flat or they're very shy. Okay, so if you raised your left hand, you were wrong. If you did not raise your hand, you were wrong. This generated tens of millions of dollars for Bing. Okay? Not something that you see every day that we have a winner that generates tens of millions of dollars. Now, I'll also say that the above change was pretty costly to implement because now we have to contact advertisers, give them a mechanism to put site links. It's a big deal to do. Large program was set up, we had to go through this. But I'll also say that there were changes in Bing that took days to develop, which were worth $100 million. Okay, those are the May experiment. There are people like, let's not do this or do this, prioritize it low. There was one that was delayed 6 months because nobody thought it would be useful. And when the guy wrote it, over the weekend, by the way, Monday morning we come in and there's an alarm that we're making too much money and something is wrong. Right? Okay, so here's the second example. Highly valuable, very interesting. Love to chat with people offline about this. Underlining. Should you underline links or not? Okay, so we got left side is an example of a search engine results page with underlines, and on the right you see the same page with no underlines. Okay? So I always have to tell you what the OEC is, and the OEC we'll use here, the overall evaluation criteria, is just click-through rate on the SERP for a query. Somebody types a query, they get the search engine result page. Do we show A or do we show B? And again, let me test the audience. Raise your left hand if you think no underline. Sorry, if you think with underlines. Raise your right hand if you think no underlines is better. And don't raise your hand if you think they're doing about the same. Okay, lots of controversy in the audience here, left and right. Okay, so if you raised your right hand, you were wrong. If you did not raise your hand, you were wrong. Underlines improve click-through rate, both for the algorithmic results and for ads, meaning we make more money. And here's the surprise. Modern web design do away with underlines. If you look at all the modern design principles, you should stop underlining. And despite the serious data that we have here that showed up for both Google and for Bing, we both gave up on underlines for the design. So we lose money when we remove the underlines, and we decided to do it for design principles. Very, very questionable industry direction in my mind. Those of you that do a lot of the design work and can explain what's going on, I'd love to chat with you about it. Okay, let me go into pitfalls. So there's a lot of experiments we run. I want to share with you the pitfalls that we see from a lot of these learnings. So first of all is p-values. I'm sure all of you are familiar with the classical mechanism of null hypothesis testing. You get a p-value, you fit in, you do a t-test, you run a p-value, and the rule of thumb is if it's below 0.05, you reject the null. And the problem is most people don't understand what it means. So let's look at some misinterpretations. One, if p is equal to 0.05, the null hypothesis has only a 5% chance of being true. This is incorrect. If you have a non-significant difference, a flat result, p-value greater than 0.05, there is no difference between the groups. That is not true either. P equals 0.05 means that we have observed data that would only occur 5% of the time under the null. That is not correct either. And then if p is equal to 0.05, if you reject the null hypothesis, the probability of a type 1 error or a false positive is only 5%. Most of the people do not understand what a p-value is. And the main idea is that when we compute the p-value, we are conditioning on the null hypothesis. Right? So take a look at number 1. The null hypothesis is only a 5% chance of being true. We are assuming it is true. Right? So what the problem is that what we really want is not this guy. The probability that x is more extreme than what you've seen. Well, we want the probability that the null hypothesis is true given something we have observed. Okay, and for that, you have to do some Bayesian corrections. More and more groups are trying to do that. So let me just give you more things that relate to that rule, which I will also put as pitfall number 2, is expecting breakthroughs. If you start with a new site, you'll get a few breakthroughs in the middle. As soon as you optimize a little bit, things become harder. At Bing, 80% of our ideas fail to show value. Okay, when we run other products at Microsoft, they're maybe less optimized. About 2/3 of ideas fail. Okay, and that 2/3, by the way, splits into about half of it equal, half of it's actually worse. So people believe something's going to work, and then it turns out to be worse than the control. I'll give you a key metric. Sessions per user is one of the key metrics in our OEC, in our overall evaluation criterion. We are only able to improve it 0.02% of the time. 1 in 5,000 treatments, somebody gets a win that we actually certify. Right? When that happens, we go through a certification process, we replicate, we try to make sure that that result is real. It is extremely rare. Most of the time, we invoke Twyman's law, which says any figure that looks interesting or different is usually wrong. So when somebody tells you that they got a 40 times lift or something because of something, unlikely to be true, very, very unlikely to be true. You look in, you drill into the details, you go through these pitfalls, and you'll find what is wrong. And we have a lot of those examples. And note the relationship to the prior pitfall, by the way. I told you before that the p.05 doesn't mean what I'm just saying here. For this case, if 5% of experiments show statistically significant movement to sessions per user, but I'm conditioning on the fact that this really, really is a hard metric to move, then most of the time, or 99.6% of the time, p-values less than 0.05 means it is a false positive. Right? So if you run an experiment and sessions per year moves, and you send it to the certification committee, we will tell you, don't celebrate yet. Most likely, this is a false positive result. Now, if you run it again, and you get another time below 0.05, then it becomes a lot more believable, right? Then you have to apply Fisher's metal level analysis, and see you got 2 experiments with low value. What does that mean? Okay, pitfall number 3, not checking for sample ratio mismatch. If you run experiments and you do not check for sample ratio mismatch, copy this slide carefully, make sure you run it. It is the most common alarm that fires for us at Microsoft. Right? So we run so many experiments, we can't babysit all of them. We have an automated system that looks at all these possible pitfalls. Every week we get multiple alerts. There is an SRM in the experiment. So what does that really mean? If you run your experiment with equal percentages, and this can be generalized to non-equal, but it'll make it easy, then you should have approximately the same number of users in control and treatment. Right? So here's an example that I got this week, an alert. There's control has 821,588 users. The treatment has 815,582 users. The ratio is 50.2. I get the alarm because I should be worried. Okay, what is the p-value of that? 1 or almost 2e minus 6. So the probability that by chance I will get such an imbalance of 50.2% is 1 in 500,000. Okay, because we don't run a lot of 500,000 experiments, this is an unbelievable thing. That means there is some flaw in the design of the experiment, or rather the execution of the experiment. And again, notice that this does not violate, I'm using p-value here, and now I'm claiming that this is the probability. That is correct, because by design, we have designed the experiment to split 50-50. So the null hypothesis is true, and therefore I can interpret the p-value as a probability. Okay, so SRM, the most important check you can do for your experiments, and you won't believe how many papers I go and look out there when I look at their data, they have an SRM. Next pitfall, wrong success metric, the OEC, the overall evaluation criterion. The OEC is one of the hardest things for us to come up with when we work with a new organization. In Bing, it took us multiple years to sort of tune and get the OEC for Bing. But here's an example. Office Online tested new designs for their homepage. Their goal was, again, to increase sales. So there's a control on the left. There's treatment on the right. You got in red, we highlighted. These didn't really show. The areas that lead to a purchase, or the purchase funnel. And the question is, which is better? You know, standard thing that they wanted to do. They had a control that is on the treatment. And the OEC was clicks on the buy button, which is in the related to these red boxes. Okay, what happened? Treatment had a drop of 64%. Okay, what happens when you see that? You go, Twyman's law. Something is wrong. That should not have happened. Nothing dropped 64%. The reason is the treatment added a price. And when you have a price, people don't need to click through. They're actually more qualified going into the funnel. Whereas on the left, the control, there was no price. People had to click just to see the price. Okay? So in this example, the lesson is measure what you really need to measure. In this case, sales. Measure at the end of the funnel what happened. Now this is hard. I remember we did this experiment. Everybody says, well, you know, it's sort of, you know, there's a certain conversion rate in the funnel. It's enough to measure click-throughs. It is not. And the second thing I want you to think about is focus on the long term. We've shown a lot of examples with short-term revenue. We actually have all sorts of things to look at long-term revenue, things that matter for the long run. And I'll just mention one example from yesterday in Pep's talk, and he was okay with me mentioning is, he had this line, what's the goal? More money right now. And that's a pitfall. You don't want the right now. You want to optimize for the long term. And a good example of why this is not a metric to optimize, you can raise your prices today, and you will make more short-term money. But you will lose customers in the long run. So there has to be some trade-off between making money today and keeping users for the long run. In the example that I showed you with the ads for Bing, the reason we keep the number of vertical pixels the same is the long term. We could show more ads, make more money, people will abandon. We know that we have to control the number of ads we show, and we do that by the number of pixels on the page that the ads take. Coming up with a good OEC is really, really hard. I think of it as one of the toughest problems that we faced when we onboard a new group. So think about search, for example. Okay? And this comes from a paper that we wrote a few years ago. We're evaluated on query share, so what percent of the whole search market does Bing have? Currently about 21%. And revenue, right? We need to make money. Okay, so here's something that happens. There's a bug being introduced into the system. The ranker that shows which top results to show on the page has a really serious bug, and the results are very poor. What do you think happens? Well, algorithmic results degrade because users have to search more right now, right? So you'll see people doing more queries because, my God, I can't find my answer in the top 10. Okay, and the ads, which were not impacted by this bug, suddenly become more relevant because they stay fixed while the rest of the page degraded. So distinct queries went up 10% and revenue went up 30%. So if I saw this result and I was optimizing for query share and revenue, I should fire the relevance team. Right? Obviously, that's not the case. So we have to think about, by the way, this problem, I saw this the other day in a book. So this problem is now in the Data Science Interviews Exposed book. So if you're interviewing for someplace, look at this problem. So what should be the metric? So here's a simple decomposition that we do. You look at queries per month, and you split this into queries per session times sessions per user times users per month. Notice, by the way, this is really simple math. The sessions cancels out. The users cancel it out. I'm left with queries per month. Nothing complicated here. The observation is that that term, queries per session, is something I want to minimize. Even though I want to maximize queries per month, I want to minimize queries per session. Now, the last term is designed by the experiment, right? So what's left is this metric. This is the most important metric we optimize for, and probably the most important metrics that many of you should optimize for. It says how many times users are coming back. Right? If you get users to come back to your site more, that's a really good winner. Another simple example that I saw a few days ago, data scientist makes an observation, 2% of query have no results. Therefore, some manager says, you must reduce this. There's a team that is assigned to minimize no results, and then the metrics improve, but what happens? I search for brochure paper, and all I get is crap or paper to clean the crap. Right? Real example from 4 days ago. So sometimes it is better to show no results. I do not have brochure paper on Amazon Prime now. Okay, next pitfall. Combining data when treatment percentages varies with time. Really, really interesting example. You run an experiment Friday, and like most experiments, we start them at a very small percentage, right? Because we're afraid, we ship code a lot, we launch 30 experiments every day, they start at a small percentage, 0.5%, 1%, something like that. It looks okay, you ramp it up to 50-50. Okay? If you analyze the results of a ramped up experiment, you can fall into what's called Simpson's paradox. Look what happened here. On Friday, treatment won. On Saturday, the treatment won. But if you only looked at the combined results, control won. Okay, people don't believe it when they see this, but you could win in an experiment or lose in an experiment, and the opposite will happen on every day of the experiment. Ramp-ups are not allowed in combined analysis. Throw away the first day, then look at the experiment as it ramped up. Or you can do more sophisticated pair tests or other things. We throw the first few. What we do is we typically launch for a few hours on a small percentage and then ramp it up if nothing egregious is happening. That ramp up, by the way, is automated, but we throw away the first period. It's small, it doesn't matter much, and we're afraid of falling into Simpson's paradox. Okay, get the stats right. This is 2 really good books on Amazon. I mean, you read them, A/B testing by the guys that founded Optimizely. Pete, you get Chris Goward with his book, You Should Test That. Both of them have wonderful stories to share. Both of them get the math wrong. Optimizely, by the way, recently published their new stats engine, which does correct it, so they've agreed. How do you avoid this? Run AA tests. Again, a critical lessons for everybody, run AA tests. Like an A/B test, except you're not really, there's no difference. It's an A and an A. And if you do not get 5% failures in an AA, if you get more or less, then you know there is a problem with the system. I've seen systems that when you run AA test, they fail 30% of the time. In fact, this is what happened to Optimizely. Their users were reporting, that the A and the AA test won 30% of the time. Should be 5. Okay, other pitfall. There's a paper with a few more pitfalls that I did not get to here. But confidence intervals, everybody wants to see percent change. Turns out you can't just take the absolute change and normalize it. You have to use a little more complex formula called Weiler's formula. You have to be careful with the computation of variance when you have metrics that are per experiment. Read more in the detail. Bots, amazing. Very lucrative business. This is a card that I saw near my house in Washington State. The guy made a lot of money from writing bots. He's proud of it. And just as an interesting tidbit, at Bing, more than half of our traffic is bots. Over 50% of our traffic to Bing is made of bots. So if we don't filter those out, we're bad. HiPPO, highest person's opinion. This was our way to change the culture. There's a box there in the corner with a lot of hippos. Hopefully you can help change the culture at your company. Here's an interesting fact. Hippos kill more humans than any other non-human mammal. Most of them are in Africa, but it does happen. People tend to step on them at night, and they don't survive well. So listen to your customers. Don't let the hippo kill your ideas. And this is sort of my summary slide. Just remember this. Getting numbers is easy. Getting numbers you can trust is hard. Make sure to check for your pitfalls. Make sure you check results are trustworthy. Thank you very much. How's that timer?